Our next speaker is Chris van Aart. Chris, welcome.
Thank you very much.
Chris is CTO and co-founder of Bolesian. But by looking at his CV, I saw that he also holds a PhD and he has an academic background. And his talk is entitled Automating Human Tasks That Are Inhumanly Large. I guess he will be giving his perspective. He will be sharing his perspective, general perspective on the first topic that comes to mind when we are talking about AI automation and how we should approach the correct way, the right way of doing it. And that will be, I guess, a nice approach by him, I guess. So please, the floor is yours, Chris.
Yeah, thank you. Thank you very much. Of course, I also have a lot of slides to show. So welcome, everybody. My name is Chris van Aart. I'm from the Netherlands.
Chris, would it be possible for you to switch to full screen mode?
Yeah, I'm afraid the problem is, well, I hope it works, but sometimes.
No, it's okay. Yeah.
Yeah, okay.
Thank you.
Thanks. So I have a background in psychology and computer science. So I can talk to people and computers and solve their problems. And this comes together in artificial intelligence. I work for a company called Bolesian. Bolesian was founded in 1985, one of the first AI companies in Europe. We are located in Utrecht in the Netherlands, just south of Amsterdam. We have close connection with a lot of academia around the world. And we also do a lot of projects in Africa, which we call under the umbrella AI for Good. And one of the things that my fascination is about the human brain and also how we know how the human brain works. So what you see here, so this guy is called patient HM. And this guy had a lot of problems with epilepsy. And they decided in the early 40s, last century, to cut some things out of his brain. So they just say, let's just open his brain and make sure he doesn't have any seizures with epilepsy. And what they did the guy lost his short-term memory. So the problem is that this guy could never ever form new memories. He was just stuck in the past. It's called antegrade amnesia. And what happened is that a lot of surgeons, let's just say, messed around in people's brain, or people were confronted with really heavy trauma with things sticking in their heads. And they found out that parts of the brain are specialized in different things. And this is a guy called Brodmann, and he came up with 52 specialized areas in the brain that are doing stuff like vision or understanding or motorics. And a lot of AI has to do with visual aspects. So in our brain, there are about 5 to 6 specialized areas in the brain that has to do something with vision. So the vision can be, okay, what do I see? What's the form? Where is it? What is it? What's the location to my brain? And the idea about is that we think, so we do hybrid AI. So we don't think there is one technique suited for a problem, but you'd have to have different type of specialized objects like in your brain to figure out how to do something. And one of the earliest things people did in the neurosciences was to look at language. So if we take this really strange sentence, before flying to Berlin, Paris Hilton walks the dog London in New York. And if you ask a computer, what's the location in this sentence? And probably the computer will say, look, I see the word Berlin, I see the word Paris, I see the word London, and I see the word New York. So they'll probably be all around the world. But we people, we are trained to understand how this sentence has to be parsed. And so before flying to Berlin, doesn't say anything about the present now. And Paris Hilton is a person. And the fact there is a dog called London is also something. And in the end, the location is New York. So with natural language parsing, and I don't have to explain to you what it is because you already know what it is, the computer can figure out where that is. So what we apply, we call it agent technology, is that we have specialized small pieces of AI that are good in a specific task. So one of the examples I want to show is about document processing. So what you see here, that you get a bunch of digital documents. We first try to get readable text using all kind of optical character recognition techniques. We also deal with all documents which are handwritten. So there we do really handwriting detection. Next, we're going to classify using NLP techniques what's in the sentence, what's going on there. And then we use knowledge rules to do all kinds of disruptions or operations to the document. And I talk about disruption because it has to do with anonymizing of documents. So in Europe, there's this GDPR ruling, which just says, okay, you're not just allowed to publish anything about persons. If you make something public, you have to make sure that everything related to persons is blacked out there. So it looks like this. So you have your letter and two images. And what we can do is by applying NLP techniques, we can figure out what all the personal data is. So this is the letter. And what you see here is, of course, in Dutch, is an address to a person. There are a couple of addresses. There are telephone numbers. There are bank account numbers. And based on NLP, we can figure out, okay, what are person names? What are things related to persons? And we can black that out. And now in the Netherlands, this is a big thing because all the government is forced that if they make stuff open data, it has to be anonymized. So this is just one example. Another example, so the greatest part of the Netherlands is below sea level. So if you ever fly to Amsterdam to Schiphol, you will be standing 6 meters below sea level. So the moment your plane lands and the dikes will break, the sea level will rise 6 meters. For we Dutch, that's really normal. Some people freak out when it happens. But we think it's normal because we've got governmental organizations, they call water boards, and they are tasked to make sure that the land is safe. And one of the things we have there are dikes, and these dikes need to be inspected. And one of the problems they have, they hire these companies like Fugro, and they will go into the field and do a lot of inspections of the dike, put it in a big document, and this is filed somewhere on a database. But most of the people, they just want to look at a map. So this is an example of a place in the north of the Netherlands. And basically they want to know where exactly did the inspections happen. So what we did, we made a program that reads the document, figures out where it is, and then shows that this is an example of a drilling. So if you do an inspection of a dike, you want to know what the composition of the soil is. And here you can put it on the map. So every marker you see here points to a page in a document. Another project, what we did was to monitor traffic between ships in the port of Antwerp in Belgium. And the idea is that just like an airport, there is traffic control that just determines what the sequence of approaching vehicles are. So at an airport, of course, obvious that are the planes, but at an harbor, they are just the ships. So there's a traffic control that just says, okay, now you're allowed to go, now you're allowed to go. One of the problems is that sometimes it goes wrong. And the problem is there are VHF channels, that just communication channels. There are about 20,000 transmissions per day. And there are only 10 people who have to monitor all this communication. But the problem is these people get distracted by all kinds of other things. And a lot of damages, so just ships colliding to each other, or ships colliding to any kind of infrastructure, could have be prevented if somebody intervened. The moment something goes wrong, mostly goes really wrong, somebody goes back to all the recorded listenings, and it takes 2 to 3 days to figure out who has caused the problem and who is responsible for that. So what we did there is to analyze all these VHF recordings. And the interesting part is that although all the shippers speak some form of English, it's really horrible English because they speak with a lot of really harsh accents. So they have Dutch accents, French, English, etc. But the point is that although you cannot understand what they are saying, you can still get a number of aspects out of this communication. And the first one is emotion. So normally a traffic controller would just say a ship like, okay, hello, you're the second in a row. And then the captain will say, okay, that's fine. The moment the captain says, oh, I don't know, or I'm in a hurry, then it means there's something going on. And there are a lot of examples where the captain is in a hurry and he wants to, get a priority. And what we did, so if you analyze the human voice, there are about 60 or 17 different features you can extract from that. And you construct what we call a voice DNA, not only to distinguish a speaker, but also to figure out what the emotion is. Next, we look at the course of the conversation. And the rule is how long the conversation is, how big the discussion is. It's an indicator that something goes wrong. And finally, we try to listen to signal words, which are mostly like, no, cannot, I'm in a hurry, you will get a report, or you have to wait for a red light. So this is another example where we listen to the human voice. Another example is also in a harbor. It's in Rotterdam in the Netherlands. And one of the challenges they have is that these big ships, they float around. Sometimes they have to park to get resupplies or to wait till they can get just the wait. So what we did there, so this is an image of the port of Rotterdam. So it's in the south of the Netherlands, close to the North Sea. And what we did there, based on historical data, we made a prediction model to say, okay, when is the best moment to park your ship there? Right. Another example is again with the dikes, as I explained before. So this is an example of a dike also in the north of the Netherlands. And one of the things here, so this image is made by a drone, and it takes a lot of time for a human expert to analyze all these images. And what you see in the rectangle is that there's something going on there. So what's going on there? Basically, this is a dike reinforced by stone, and the sea just flushes to this all these stones. And what you see here is that stones are missing, which means that the structure is deteriorating, and it means that someone has to fix these holes. And what we did there is talk to an expert. So if you look at this image, what's wrong here? And he just says, well, if you see all the small black shadows, it means that stones are missing, and the stones are missing. That's a bad sign, because it means that the dike is getting weak, and we need to repair that. Another example is also again with water, and this was the inspection of waterway markings. So the idea is that we have, I can show it here. We have it's called buoys. They're big markings, so the things you see here on the left, and these are meant to indicate the rules on the waterways. And one of the problems is that now they do this inspection manually. So every month, 2 people on a boat, they're driving by all these markings to see if they're still there and that they're not afloat. And the question was, can you make a really simple solution to help these digital inspectors? So if you look really closely, you can see in the mirror of the image, you can see a guy sitting. That's the captain there. So we made a really simple Android application, and we trained with a simple neural network to identify all these markings. And based on the GPS and the compass, you can figure out what actually is. And on the right side, you see the official infrastructural map, and there you can compare your findings. So the idea is that if you find a buoy or a marking, it should be on the map. And if not, then there's something going on. and all the way around. If something has to be there and it's not there, then there's something going on, and then the people there are alerted that they should figure that out. Okay. Next, we go from roads to roads. So what you see here, this is a typical. It's comparable with a Google Street View car. So this car drives around with a 360 degrees camera on top of it, and they use this to inspect the roads. One of the problems, if you want to inspect the road, you can go there, but you cannot drive and inspect at the same time. So they take a picture every 3 minutes, and you get a recording like this. So what are we looking for? In this case, we are looking for cracks in the road. The cracks, if you have a crack in the road, it means that if you get some water in and it starts to freeze, the crack will open up, or the crack will get even worse if there's a lot of traffic going on there. And what we did here, so we talked to experts to figure out what's going on here. And this is one of the nice examples where machine learning doesn't work. And the reason here is that all these cracks you can see here indicated in the red rectangles, is that every crack has a unique form and layout. So what the inspector does, it looks like, okay, what's a normal situation? So a normal situation is without a crack. And the moment there is a crack, say, look, there's something going on. But he doesn't see that in terms of the form or the layout or the color. It just sees, okay, look, there is something going on. So we have examples where people try to train a neural network with all kind of cracks, all variants of them. But the point is that all these cracks have unique properties. So what we did here is to apply computer vision, the same as what the inspector does. It just looked like, okay, what's a normal situation, and when is something off? There's something off if you can identify some form of a crack. And then in the end, so all these small rectangulars, you can plot them on the map, and this is how we report this back to the government, who takes care of the quality of the roads. Another example is the identifier of markings. So the markings, they not only indicate the layout of the roads, but also rules on the streets. And one of the obligations the government has to make sure that the markings are always visible. So the moment the marking is not visible, it means there can be a dangerous situation. So what this system does is not only identify that there are markings, they actually very easily to identify the right things on the road, but also classify what kind of markings there are, and based on the markers, you can say something about the layout of the road. Another thing I would like to show us finally is again with road inspection, but this case with inspection of assets, and specifically our utility poles. So this is a recording of a part in the United States, and what you see here are poles with electricity guiding electricity. The nice thing about these Google Street View kind of cars, that they have a GPS location, and if you want to know exactly where they are, you have to identify at least on 3 separate images where they are. So what you see here on the left top is the original picture. Next to that, we do a segmentation. So the segmentation says, okay, what's road, what's green, what's the sky, and where do we see things standing up, which can be poles or utility poles. There are different kind of poles, so you get mailboxes, traffic signs, etc. But these electricity poles, they have a specific layout. Then we try to find the same pole on 3 separate images, and using triangulation, you can then figure out what the exact GPS location is, and then you can put it on a map, and in the end you can export it to CSV or a shape file. So I didn't want to explain what AI is. I just give you a bunch of examples of projects we are doing here. And I would like to thank you for your time.
Thank you for your presentation and for all these real life examples. It was very valuable. Thank you very much, Chris.
You're welcome.